Hello everyone, today we'll be learning how to expand binomial products. Our learning goals for today are to know how to apply the distributive law to binomial products and to expand and simplify binomial products. So what's a binomial? A binomial is an expression with two terms. For example, x plus 2 or x cubed plus 1, but not an expression like x squared plus 11 plus 24. This is because this expression has three separate terms, and that makes it a trinomial, not a binomial. So, to expand binomial products, we use the distributive law. The distributive law is a plus b times c plus d is equal to a times c plus d plus b times c plus d. And if we expand this, that becomes ac plus ad plus bc plus bd. This is also essentially the same as a plus d times c plus d. It is the same thing as just multiplying this with this and this with this. So let me give you some examples of expanding binomial products. So 2a minus b times 3a plus 2. The first step to expanding this binomial product is multiplying this with this and this with this. So 2a times 3a plus 2 minus b times 3a plus 2. And if we expand this, it becomes 6a squared plus 4a minus 3ab minus 2b. And just keep in mind that it is minus because you're multiplying a negative number with a positive number. That is always a negative number. And we cannot simplify this because there are no like terms, so this is the final product. Another example is 4x minus 3y times 3x minus 4y. And if we expand this, we have to multiply this numeral by these and this numeral by these. So it becomes 4x times 3x minus 4y plus, actually it's not a plus, it's a minus 3y times 3x minus 4y. And we can expand this, and that becomes 12x squared. We're multiplying these two. Minus 16xy minus 9xy plus because you're multiplying a negative by a negative, that is always a positive, plus 12y squared. And this has two like terms which we can subtract from each other. So this becomes simplified 12x squared minus 25xy plus 12y squared. That is our final product. So let's take this a step further, and we're going to work out some missing terms in these expansions. So x plus 2 times by two unknown terms is equal to 7x squared plus an unknown term plus 6. So let's do the first step, which is multiplying one term by the other ones and this one by this one. So x times this plus this plus 2 times this plus this is equal to 7x squared plus something plus 6. Now we can see that we can get 7x squared with x if we put a 7x here, because x times 7x is equal to 7x squared. Since there's a 7x here, there must be a 7x over here as well. And we can see that we can get a 6 if we multiply 2 by 3. So we put a 3 here. And yeah, let's expand this and see if we get our final answer. 7x squared plus 3x plus 14x plus 6. That becomes 7x squared plus 17x plus 6. And yes, we got our middle term. So this is 17x. Let's do another example of this. So we can do something minus something times 2x minus 1 is equal to 6x squared minus something plus 4. Okay, so what we can do here is we can multiply this by this and this by this as we did before. So 2x times something minus something plus, let's just do a minus 1 to make this simple, minus 1 times something minus something is equal to 6x squared minus something plus 4. So we can see that if we multiply 2x by 3x, we can get 6x. So we put a 3x here, and therefore there must be a 3x here. Minus 1 times minus 4 is equal to 4. So we put a 4 here because there's already a negative here and here as well. And we can expand this, so that becomes 6x squared minus 8x minus 3x plus 4. And we can get a middle term. So if we subtract the like terms together, 6x squared minus 11x plus 4. So we know that the middle term is minus 11x. Okay, but what if we don't have any numerals in the binomial product except for x? Let's do a question like this. So x plus a times x plus b is equal to x squared minus x minus 6. So we know that we're going to get x squared by multiplying x with x squared. Our clue here is the minus 6. Minus 6 tells us that a times b must be equal to minus 6. So a and b can either be equal to 2 and 3 or 6 and 1. However, they must also add to get minus x. So basically minus 1. And that's how we know that it has to be 2 and 3. Because minus 3 plus 2 is equal to minus x. So we can do 6. So, sorry. X times x plus b plus a times x plus b is equal to x squared minus x minus 6. And let's substitute in minus 3 and 2. So let's make b minus 3 and a is 2. So this is also minus 3. So if we expand this, it becomes x squared minus 3x plus 2x minus 6. And if we collect the like terms together, it becomes x squared minus x minus 6. So we know that b is equal to minus 3 and a is equal to 2. And we solve this with trial and error. So let's apply this rule to a problem-solving question. A rectangular room with the dimensions 4 meters by 5 meters is to be extended. Both the length and the width are to be increased by x centimeters. So the area here is 20 because 5 times 4. And now we have to increase the length and the width by x centimeters. So it becomes 5 plus x times 4 plus x, which can also be written like 5 plus x times 4 plus x. And this is a binomial product, so we can expand it. It becomes, if we expand it, we got to multiply this by this and this by this. So 20 plus 5x plus 4x plus x squared. So that becomes x squared plus 9x, I just rearranged it to make it easier to read, plus 20. That is our expanded expression. And we can solve this expression if we substitute 3 into x, so that becomes 5 times 4 plus 3 plus 3, because we're multiplying this by this and this by this, plus 3 times 4 plus 3, and we can easily just simplify that because 4 plus 3 is equal to 7, and here, so that becomes 35 plus 21, which is equal to 56 centimeters. Sorry, I don't know why it's not letting me write centimeters squared. Okay, centimeters squared. So we can tell how much the area has increased if we subtract 56 centimeters squared from 20 centimeters squared. So that should be 36 centimeters squared. That's how much the area has increased by. Let's do one more problem-solving question to strengthen our understanding. So, the outside edge of a path around a swimming pool is 15 meters long and 10 meters wide. The path is x meters wide. So we need to find an expression for the area of the pool in an expanded form. So this is easily solved if we just make two separate rectangles with the dimensions that have been given. So the big rectangle is 10 times 15, and the smaller one is 10 minus 2x, because this length is x and this length is x. So to find this one, this small little length, we have to subtract 2x from 10. And the same logic is applied to find this length here, 15 minus 2x, because this is x and this is x. So then the expression for the area of the pool should be 10 minus 2x times 15 minus 2x. We can expand this by multiplying this with this and this with this. So 10 times 15 minus 2x plus, let's just simplify it by not adding a plus. So minus 2x times 15 minus 2x. And this becomes 150 minus 20x minus 30x plus 4x. And this becomes, oh sorry, it's not plus 4x, it's plus 4x squared. So this becomes 4x squared minus 50x, because we're collecting the like terms, plus 150 should be your final answer. And let's find the area of the pool if x is equal to 2. So I just need to see what it is again. 10 minus 2x times 15 minus 2x. So let's substitute 2 into x. So that becomes 10 minus 10 plus 4 times 15 plus 4. And that is 14. Oh, okay, hang on. It would just be easier if we simply expanded it. So this multiply with this, and this multiply with this. So 150 plus 40 plus 60 plus 16. And this becomes 100 and sorry, I have made a error. This has to be minus 4. I'm sorry. And this is minus 4. So this becomes 150 minus 40. Minus 40 minus 60 and plus 16, because you're multiplying two negatives, which makes a positive. So this becomes 110 minus 60 plus 16, which becomes 66 centimeters squared. That is our final answer. And let's do extension. I'll explain this question to you. Basically, to calculate trinomial expansions, we use the same logic applied as before. We multiply this numeral, this term with this term, and this term with this term. And that becomes 4x times 2x squared minus x plus 7, minus 7 times 2x squared minus x plus 7. And if we expand this, we get 8x cubed minus 4x squared, plus 28x minus 14x squared, plus 7x plus minus 49. This is complicated, but it is easier to simplify if we group the like terms together. So if we group them together, we get 8x cubed minus 4x squared minus 14x squared, plus 28x plus 7x minus 49. So we subtract minus 14x squared from minus 4x squared, and we add 7x to 28x, and our final answer is 8x cubed minus 18x squared plus 35x is equal to minus 49. So this is our final answer. Thank you for watching. Consider watching our video on 8b, perfect squares and the difference of perfect squares, to expand your knowledge.